Welcome to Brain Vision.
To solve part A, we're going to consider the fact that the energy is conserved. So the energy of the transition from M to 1 is the same as transitioning from M to N and then N to 1. And in general, energy is equal to hc over lambda. So we can use this expression to get everything put in terms of the wavelength lambda mn. So replacing all of these energies with hc over lambda, we realize that the hc is going to cancel out because it's the same in all the expressions. So you can just divide that out. So what we have here is 1 over lambda m1 is equal to 1 over lambda mn plus 1 over lambda n1. So we can just rearrange this to solve for lambda mn. So what we have here is 1 over lambda mn is equal to 1 over lambda m1 minus 1 over lambda n1. So to solve for lambda mn, we just need to raise both sides of this equation to the -1. So what this gives us is 1 over lambda mn, because we raised both sides to -1. So lambda mn is now in the numerator and not in the denominator, is equal to 1 over lambda m1 minus 1 over lambda n1, all raised to the -1. So we can box this in as the solution for A. Now for part B, we're told to replace our values for lambda by the expression 2 pi over k, and then prove that solution there. So what we have here, so lambda is equal to 2 pi over k, so we have 2 pi over k mn is equal to, we have lambda's on the bottom on this one, so we're going to have km1 over 2 pi minus kn1 over 2 pi, all raised to the -1. Now this time we want to solve for kmn, so we once again need to raise both sides to the -1. Doing that cancels the -1 on the right side, and it inverts what's on the left. So what we have here is kmn over 2 pi is equal to 2 pi over km1, or nope, sorry about that. The -1 is canceled in this case. So the right side stays the same, but we got rid of that -1 on the outside of the parenthesis. So it's km1 over 2 pi make that m look like a subscript. There we go. Minus kn1 over 2 pi. So all the values have a 2 pi in the denominator. So we're able to go ahead and cancel that out. And since our value of K always has to be positive, we have Kmn must therefore be equal to the absolute value of Km1 minus Kn1, which is what we were asked to show. We can box that in as the solution to our question.